lesson, in fact. Let me see. Oh no, it's mixed in with this one, yeah. Simple circuits, Ohm's law, and IV graphs. Yeah. Okay. Are we recording? Yeah, we are. Okay. Can we see? Yeah, we can get that down. Oh, when I got on my bicycle yesterday, I noticed the seat was a little lower.
I want to when I want to go outside the school. I remember this. I want to change
the seat.
Yes. But I don't want to go back.
Yes. Yeah.
So.
Yeah. You should. Where do you want to study next year? Next year, where are you going to study? What university? Do you know? It's a secret?
Not secret, just
Ireland
not actually.
Okay. Maybe you should buy a bicycle.
Yeah, I consider buy a bicycle.
Yeah.
Near
I think bicycle is only too useful.
Yeah. You need a bicycle in Dublin.
Yeah.
But it's raining is not common.
What's that?
Raining.
Yeah, the rain's a problem. Yeah.
I have a bicycle, but never.
Well, today is okay. It's a little windy.
It was very windy in the morning.
Huh?
I'm living in school.
You live in school?
Yeah.
Oh, they don't need a bicycle then. You're fine. You're fine. Okay, you got that?
Yeah.
Yep. Okay. So, a few things to do. Okay. Now, you don't have to write this down. No, this is okay. An electric circuit is a path in which the electrons from a supply, a source, flow. The electric current flows in a closed path. And the point where the electrons enter is called the source, and where they leave is called the return. So look, you don't need to write this down. No, don't. It's okay. You know this already. To have a circuit, okay, it has to be closed. What happens if I open this? Yeah, we don't have a circuit, do we? So the current comes here, goes along, and then goes back in here. I mean, you know, this is baby physics. You know this, right? And you know that if I remove this or I open this, no good.
Like if you remove the black cord, you won't.
Yeah, nothing happened. No, this is gone. Light is off. But you all know this, right? Like I said, this isn't even middle school. This is like elementary school, right?
Science.
Yeah, basic science. Basic science. Now, of course, we can't draw beautiful pictures like this every time. We need to use symbols. I think some of these symbols you might know. There are so many of these symbols, like maybe 100 of these symbols, and I asked NCUK if they could give me a list of all the symbols, and they said no. So the symbols I'm going to give you are the ones that I think they should only use for the exam, looking at what's in past exams and so on. But this isn't all the symbols, because I mean I couldn't give you all the symbols. There's like 100 of them, you know. So these are the symbols. Now before you draw that, I also left there's some space in case I need to add more in the future. This one is a switch. This one is a cell. This one is a battery. This one is a lamp, a light. Yeah, light. Voltmeter, ammeter, resistor. We did resistor yesterday. Variable resistor. What's a variable resistor? Variable resistor. Change resistance. This one, does anyone know what this is? Is LED diode.
Yeah. So it current from this.
Yeah, the
current
current.
pass, but if from this, it cannot.
Yeah, the current can pass this way, but it can't pass this way. It's forced. It's like one way. But what is it? What does it look like? An LED diode. It's a light. It's a little light. And this one light dependent resistor.
Oh, so the resistor is connected with light.
Yeah. And how does the light affect the resistor?
There's a light.
I think.
This is high.
Yeah, I think, I'm not 100% sure, but I think as it gets brighter, then you get more resistance. And less bright, less
I
resistance.
think that the question will tell me.
It doesn't? Well, no, maybe it does. It should. I hope so. Anyways, this is what happened, okay? Last year I had only these symbols, but then in the exam, they had this, which was new, which annoyed me because I didn't do this with my students because they've never asked it in the exam. And this is what made me ask NCUK, do you have a list of the symbols? And they said, no. I said, can I have a list of the symbols? And they said, no. They just said, use the standard symbols. I'm like, but there's 100 symbols. Like, which ones? You don't expect me to teach all 100 students, you know? Anyways, there's a very, 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 very small chance, maybe 5% chance, that you'll see a symbol not here that's new. But I mean, that's just life. There's a small chance, you know. Okay, so you should copy these ones. At 1 o'clock, you have Neil as a teacher, don't you?
Mm-hmm.
At 1 o'clock, Neil is doing a training lesson where he's going to train teachers on how to use writing pads. I'm going to ask him if I can skip this lesson.
Maybe teach him.
Maybe I should teach him.
I think it's not very interesting.
It's going to be boring.
Did you watch Champions League last night?
No. I was too tired yesterday.
Yeah, Liverpool lost.
Liverpool lost. Who were they playing?
Atletico Madrid.
That's not really surprising, is it?
Yeah.
It is surprising.
Yes.
You would have thought Liverpool won. Really?
Because they play in Anfield. Yes.
Oh, it was at home.
After
What was the score?
Last year. 3-2.
Exciting. Any money bet?
Of course not.
Okay.
I betted on Liverpool, so I lost.
You would have lost, yeah.
Well, the one before that, I made like 50.
Did you?
Yes, no. I was happy yesterday when I came to class.
If you notice, he ate like 2 packs of bread.
Oh, this was his celebration.
2 packs of bread and I think cocoa.
And you didn't buy your teacher a Coke with your money you won. Bad form.
The longest side is the plus, right? For 7.
Yeah, sorry, I should have said that. This side is the plus and this side is the minus.
Maybe there will be temperature dependent resistance.
Maybe one day there will be in the exam. Perhaps, yeah. Yeah. Say again?
For capacitors.
Oh, that would be in its own lesson. That we have capacitors in a separate lesson. Yeah. See, I have one bet here in my wallet. It's quite old. I bet it last year. This is Joe Biden, next US president. €2. So I really hope it's not Trump again. You know? So I'm holding on to this. Actually, I need to. Yeah, it's starting to fade.
Wait, you bet €2 to get what?
I think about €8.
That's how it works.
I mostly did it because I don't want Trump to be president. So, and I was thinking, who is most likely if it's not Trump? Like, well, maybe Joe Biden. And it turns out maybe it will be Joe Biden. He's doing quite well. Right, have you got this? Yeah.
Almost.
Who do you bet with? Are you even old enough to bet? Are you a minor?
That's between me.
Oh, now be good. All right, you got that?
Yeah.
No.
Hey.
Yeah. I'm going to move on. Okay. So I think you know these words already. Series and parallel. If two things are in series, they look like this. And if they're in parallel, like this. This is series, this is parallel. Okay? I would like you to draw this though. If you can draw. Marwan, what's your home country? Is betting legal or illegal? In your home country? Betting. Place a bet. Legal or illegal? Illegal? Okay. Your home country?
Nigeria.
Yeah?
Very
Legal.
legal.
Very legal.
Yeah.
Always advertised.
Alright, okay.
Like major source of income.
Yeah, you notice it's pretty popular here too.
Yes.
Pretty popular here too. And I don't have to ask, I know in China it's popular too. Right?
Because we have a lot of population.
Yeah.
You can control them.
Yeah.
1/5 of the population in the world.
Is it that many now?
Yeah.
1 in 5.
They are too much. That's why when you go anywhere in this world, you will see plenty Asians.
They're fairly spread out throughout the world, isn't it? Yeah. Any country you go to, you'll find Asian students. Yeah. True, right? I'm sure if I go to a school in Nigeria, there'll probably be some Chinese students
yes.
in there. Yeah.
Like even where I live,
Even in my class.
estates where I live, there like
There's a group. Yeah.
there's a whole mall called Panda and it's old.
Really? Really? That's mad. That's mad. You have a Chinatown in Nigeria, do you?
Probably this.
Yeah.
Most likely
Yeah. Yeah, okay. What about in Oman as well? Yeah.
Actually, now there will be more Asians in Nigeria because they're the construction company that's building.
Yeah.
Chinese workers. Yeah.
CECC, right?
Chinese workers.
Yeah.
Yeah.
You just come with their kids and
Yeah. Okay, little bit of basic English now. So, one battery is not called one battery. We call it a cell. If you have one. Okay. Two or more cells, that's called a battery. So, I have a 3-volt cell. That is right. I can say that. I have a 3-volt cell. I have 2 connected 3-volt cells. Therefore, I have one battery. Right or wrong? This is right. You can say that. I have 3 3-volt cells. Therefore, I have one battery. This is right. I have 2 connected batteries. This is wrong. Okay? Don't say this. I have a 3-volt cell, therefore I have one battery. No, wrong. Wrong. You never. If you have only one, it's always a cell. If you have 2, it's a battery. If you have 2 cells here and 2 cells here, that's a battery and that's a battery. Yeah? If you put these two cells and these two cells together to make 4 cells, that's still a battery, one battery. So basically, it's kind of like cell is singular, battery is plural. Now, it's not really. It's kind of like this. Do you understand? No? Now, I know it can be a little bit confusing because, like, for example, this here, you would call this a battery, but really this is a cell. I put 2 of them together, now I have a battery. There's a bit confusing. Now, it gets even more confusing, I'm afraid. So if I look at my laptop, what do you call this? You call it a battery. Is it a battery? Yes, it is. Because this battery here, you can't see it, but inside of it are, for me, 4 cells. Yeah. I don't know if you've ever done this before. Has anyone ever bought a replacement battery for their laptop? No, well, if you do, when you buy it, you notice they come in 3 types, usually. You can get like a 4-cell battery, a 6-cell battery, or a 9-cell battery.
You can do that for inbuilt batteries too.
I'm not sure. I just know for my one, like when I was buying it on eBay, I could buy a cheap 4-cell battery, or I could spend more money and get like a 6-cell battery, and the 6-cell battery obviously gives me more time, power, you know. And a 9-cell battery would be like, whatever, like 12 hours or something, you know. So this one is really a battery because you can't see it, but inside of it there are 4 cells. Okay. Say again? Yeah. Because I don't know how, but I guess with the 6 cells they must use a different technology to make it smaller. You know, more expensive maybe equipment. I don't know. Yeah, it's okay. So I don't know for my phone if it's a cell or a battery. I feel like it's a battery as well. So I feel like that it probably has 4 cells in it as well. I don't know. Yeah, it is. It's very complicated. Yeah. Sometimes the big batteries, like AA, I think an AA battery is still actually a cell. But yeah, no, I think, you know, all these little guys here, these are all cells because they all have 1 cell inside them. Yeah, so we shouldn't call them batteries. But I know if you go into a shop and you say, I need to buy an AA cell, they'll be confused. Yeah. Right. Okay. So is the English okay?
Yes.
Yeah. Right. Now, some formulas, our first formulas. So when we're talking about a series, current is constant. So I'll just draw out what I mean as well. So for example, if I have say an ammeter here, and I could even have another resistor here, and I could have an ammeter here, and I could even have another resistor here, it doesn't matter. If I was to measure the current here, I1, and measure the current here, I2, I discovered that they're equal when in series. Okay, so that's our first law. In series, current is constant. Can you write that down? That's like our first rule. You got that? Yeah? Next rule. Resistance is additive. So what that means is, let's say that this guy here had resistance R1 and this guy here had resistance R2. Then the total resistance would be R1 plus R2. Resistance adds. So a 1 ohm with a 2 ohm would make a 3 ohm. Okay? Yeah. So that's the second formula.
Can you put a small t?
Say again?
Can you put a small t as a subscript like RT? Is this
You can. We don't usually, but you can. Yeah. Continue?
Yes.
voltage is different and additive. Now I'll explain that here. I'll just draw it again. So let's say here and here. You measure the voltage here, V1. You measure the voltage here, V2. V1 and V2 will probably be different. Okay? I mean, they could be the same, but I mean, if these guys are different, then these guys will be different. Okay? And also, if you put one large voltmeter around everything to get the total, you'll discover that the total voltage will equal V1 plus V2. So for example, if this said 6 volts and this said 4 volts, then this one that covers both would say 10 volts. So voltage is different and adds. Continue. Okay. Battery. Plus with minus causes an increase. Let me explain with my little batteries here in my remote. Sorry, my cells in my remote to make a battery. So, can you look up? Which side is the plus? Can you tell, the left or the right? Which is the right, yeah. So if you take a plus and put it with the minus like that, then you make the voltage bigger. If this is 1.5 and this is 1.5, and you put them together like this, you'll make 3. Okay. But if you put them together the wrong way, minus with minus, then the voltage decreases. Does anyone know what voltage I would have? 0, yeah, because they cancel. So if this was, say this one was 2 and this one was 1, 2 and 1. What do I have now like this? 3. And like this? 1. Okay? So
you turn that into like a resistor or something.
basically, yeah. So plus with a minus causes an increase. They add together. Got that? Continue? Continue, folks, yeah? And the other way around is a plus with a plus or a minus with a minus causes a decrease. Okay, now, parallel. Current is different and adds. So, in this picture, for example, you have a current here, I1, and you have a current here, I2, and they're in parallel, and they come together, then what happens is they add. And usually these currents are different as well. Okay? So the first rule is they're different and they add. Yeah. Right, next one is voltage. Does anyone actually know voltage? Yeah. Oh, sorry, I'll do resistance next. It's the reciprocal that adds. So, yeah, I think some of you know this one, right? If you have here an OR1 and you have here an OR2 and you combine them, that is equal to 1 resistor, and the formula for it is this. So you can combine them mentally into 1 resistor using that formula. Yeah? So that's the resistance one. And then the voltage one, who said? Someone knows? Yeah. Voltage is constant and equal. So for example, if you have something here, and you have something here, and this one is R1 and this one is R2, and you measure the voltage here V2, and you measure the voltage here V1, you discover that V1 will equal V2. And by the way, what if you do put a voltmeter around the whole thing? It's the same as well. Yeah. And the battery. What about if the batteries, or rather, sorry, the cells, if I put the cells in parallel, or if what way does they work? So if I have a 1.5 and a 1.5 in parallel, yeah, we'll study this later. It's a little more complicated. No, they're not actually. You can't quite tell, but although it looks parallel, this is in series, because there's a connection at the top of that one into the bottom of that one. So they look like they're in parallel, but in fact, for all electrical appliances, I think they put them in series, because they want the voltage to add up to make a bigger voltage, you know. Oh, yeah, okay, if you want, yeah, it's okay, yeah. It's more complicated.
No, because like 1 over R.
You would forget that, but remember the other formula.
Yeah.
Okay.
Just
As you
like
wish.
you would remember.
No, I know. I know what you're going to say. It's all right. All right. Continue. Yeah. Right. Let's look at our first example. 4 resistors make a square circuit, and the resistors are sizes 1, 2, 3, 4 ohms, and there's a 5-volt battery here. I want to find all the currents. Okay, so I'll draw this and we'll do it together. Which way is it? Sorry. 1, 2, 3, 4, and 5 in the middle. This one is a 1. This one is a 2. This one here is, that's a 1, 2, 3, and 4 ohms. And then down the middle here, that is a 5-volt supply. Now what I'll do is I'll add these two guys together. Yeah, so, how will I put it? I'll just put it there. What is this one going to be now? 3. And then this one here is going to be 7. So that's equal. Okay. Now what I can do is I can leave the tray here like this, but I don't know if you can picture. Imagine I picked this up. I kept it connected. I just picked it up and moved it and put it here. So it's like sitting over here like this. Do you get? Like I like lifted it up and just moved it. I haven't changed anything. But the reason I did that is so it becomes very clear what is the relationship between the 3 and the 7. It's parallel, isn't it? So that equals let's calculate. 1 over R is 1 over 3 plus 1 over 7, which is, yeah, okay. So R is 2.1. So we know the R, and we also know the V, don't we? So if I use my VIR triangle, V, I, or triangle. I can get the I. So what's the I here? 2.4 amps. Okay, so let's go backwards now. So here is 2.4 amps. So it means here is 2.4, here is 2.4, and back at the start, this part here is 2.4. Okay, but the problem is now, I would like to know what is the current here in red. Well, again, I can use this triangle, can't I? The V, what's the V? The V here, here, and here, what is it? It's still 5, yeah, why? Because they're all parallel, aren't they? So I can have V, I, and then I can do the 3, and then the 7. Because I can do each of them. Okay, so can someone type in 5 over 3 and then 5 over 7?
1.67.
Is that the 5?
Yeah.
Yeah, oh yeah, of course, yeah. So 1.67 amps, and then the outer one?
0.714.
0.714 amps. Now, if I go back to this picture, which one has the 0.714? The 7, isn't it?
Yeah.
So here is 0.714. But if I go to this picture, is it still 0.714 or is it different? It's still, because it's in series, isn't it?
Yeah.
So here this is this current here is 0.714. 0.714 amps, and I'll put it in green. This current here, what's this one?
1.67.
1.67 amps, and then I'll put it, oh, I don't have brown, okay, I'll put it in black here. This current here,
2.4.
where's it gone? Yeah, where's it gone? Oh, there it is. 2.4 amps. So there you go. I have all the currents now figured out. So I like this one. This is a nice little example of practicing our rules, because I think we have to practice all the rules. So do your best to copy this one in your notebook.
I have a question.
Yeah.
Is it because, like, after you did the 1, 2, why didn't you just continue 3 plus 3, 6 plus 4? Why didn't you
Hang on, 3 plus 3?
Like, yeah, you got 3.
Yep.
And then why didn't you just continue like that? Why did you?
I'm not sure what you mean. Which picture?
Like,
1, 2,
the
3,
first
4.
one you did 1 plus 2 because it's in series.
Yeah.
If you keep going.
No, because the 3 and 4 aren't in series with the 1 and 2. I know it looks like it.
Or is it because of, like, the wire?
Yeah, yeah. The relationship between these actually is parallel to this. And that's easier to see when I move the wire onto the other side of it, like in this picture. Bello, your point is well taken, though. It is not always easy to tell if things are series or parallel. It really looks like they're in series because they're all lined up in a block, but in fact, they're parallel. 2 of them, 3 and 4, is parallel to 1 and 2. Now in a later class, there's a very bad example where it really, really, really looks like they're in series, and I used to think they were in series, and all the students are certain that they're in series, but then they're in parallel.
And it doesn't say so in the question?
They might say it in the exam question, yeah. And anyways, it wouldn't be as unclear in the exam as this. Ooh. All right, continue. Not yet. Okay. continue?
Yeah.
Oh, not again. It was so sunny like 10 minutes ago. Terrible. How far do you walk to school, Aoife? I saw you walking this morning. Do you have far to come?
No, 7 minutes.
Oh, so close. But you were coming through the houses, so are you like in student apartments? Or?
No, homestay.
Oh, you're in a homestay, alright, okay, yeah.
Homestay?
She's in a homestay.
Near, so near.
Yeah, so near, I know.
Why my homestay needs 1 hour and 50 minutes to go to school?
I don't know, maybe she's in a VIP homestay.
Oh,
It's a special homestay?
No.
No?
Oh, why?
She got lucky, I guess. How many's in the homestay?
Just be like
But I mean like you, and how many's in the family?
4.
Alright, so it's you plus 4 or you plus 3?
No, there are 4.
Yeah.
And I'm the 5th.
Oh, you're the 5th one, okay. Alright, that's pretty big then. Well, how big is the house though? 3-bedroom?
I don't know, but I have the whole floor.
You have the whole floor?
Yeah.
The whole floor?
Yeah.
Are you sure?
Yeah.
Okay.
How much?
Yeah, so it's
How
private.
much?
She must be paying loads of money.
Oh no.
No. Don't tell Ming, she'll be upset. Where is your homestay?
In 24.
Dublin 24.
Yeah, distant.
Ah, that's not that far. If you Dublin 24,
You
That's-
live in Dublin 24?
That's
Not past.
Hey, the
Oh.
you could cycle in half an hour,
50.
15 minutes. It's not far. See, he can cycle to Tala in 15 minutes.
But sometimes it's raining in the morning. Every
I
day.
know.
Just one street.
I know.
You also cycles.
Yeah.
Almost
I cycle every day.
If I take a bus
1 hour.
1 hour,
Yeah,
take a bus.
yeah. It's terrible.
I must say,
Stop
there's some
like
conditions.
20 times.
Yeah. Bus is too slow here.
Yes.
Too slow. Right, you got this now, Bello? Yeah, okay. So, next now. This circuit here, you need to know this circuit for the exam, okay? Let me explain it here. So, wait, don't draw it just yet. I want to explain what happens here. The voltage here is V, and the voltage here, I don't know, is it going to be the same or different? Different. So what I'll do is, we can call the voltage on the top V, and the voltage on the bottom here X. And we'll call this voltage here, we'll just give it a name, we'll call it E. Now, this E, will it stay the same or will it change? What do you think? Well, it'll stay the same, won't it? Like for example here, this is a 1.5 and this is a 1.5 and that's it. They don't change, okay? But what happens to the X? You can change the X, can't you? So it must be that E equals V plus X. But if you make the X bigger, what must happen to the V here? Must be smaller, because the total still needs to be E. For example, maybe this is 3 volts. So if you make the X 2 volts, then what happens to this one? It must be 1 volt. Okay? So basically what I'm trying to say is, as you change this guy, what happens to the number here? It'll change. So basically changing this has the effect of changing this number. What will also happen though is the number here will change because of the formula VIR. The I equals V over R. Okay? So changing the V will cause the I to change as well. So by changing this, you can get different different voltages and different currents. And what we would like to do is then to make a graph. We put the voltage here and we put the current here, and we'll look at what graph we get. So this circuit lets you make what's called an IV graph for this resistor. Okay, I'll say that again. This circuit is important because you can use it to make an IV graph for this resistor. Now we'll talk more about that in a moment. Before we do, I want you to draw this, and you must remember this circuit. It's an important one.
So it will be like a practical on it.
Correct. You probably did this one, yeah? When I was cycling this morning, my chain, you know the chain? It fell. It fell off. So I had to put the chain back on, but it meant my hands were
Yeah.
covered
That's very
in
normal.
grease and oil.
It's too bad.
I was cycling, and then all of a sudden, I was cycling, but I wasn't going forward anymore. And maybe I cycled too fast. Yeah. I did. I pushed it until I could fix it later. Okay, you got that circuit? Yeah. So here's an example. Okay. Here's the voltage and here's the current, for example, and we'll make the graph. Now, we won't be super accurate, okay? We'll just draw it roughly. So here's an example you can copy down. My voltage goes from 1 to 10, doesn't it? So this is a potential difference in volts, and this one is current in amps. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what about my current? Goes up to 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Like that. Okay. The first one is 1 volt gives me 2 amps. Then the next one is 2 volts gives me 4 amps. And, well, you will not be shocked to discover that the graph you get looks like this. But before you draw that, what does the slope represent? Not quite.
1 over R.
Yeah, the slope actually represents 1 over R. So the slope here will equal 1 over R. So then that means the R will equal 1 over the slope. Now, remember, Bello, I was saying we don't use the ohm meter to measure resistance. It's not accurate. But by using this circuit and this graph, we can measure the R. And that's one of the experiments you'll have to do for me. You'll have to make one of these graphs to calculate the R. Okay? So, can you copy this graph down?
During the experiments, you already give us the values.
No, you collect them using the voltmeter and the ammeter. Okay, can you add that to your notes? Continue? Yeah. So look, this graph, you can call it the IV graph, but its proper name is called the IV characteristics. And the IV characteristics of a resistor is a plot of the current and the voltage when you change the voltage. So this graph here, this is called the IV characteristics graph for the resistor. So if I just go back here, this guy here, if somebody said, what is the IV characteristics for this resistor? The answer is this graph. Do you understand? Yes? Yeah. So, the IV characteristics is the plot, the graph of the current and the voltage when you change the voltage. Can you write this definition down? You need to know this definition. Okay, who am I missing?
You cannot learn for the GNI.
Oh, that's right. I am missing Son, Kehong, Peter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Abdullahi. Where's he?
GNI also.
Him and Peter.
Yeah.
And Son is at the bank. And what about Kehong? He's been very sick, hasn't he, lately? No. He was sick well before coronavirus started. Okay, you got that? Yeah. Okay. Now, does anyone know Ohm's law? Does anyone know Ohm's law? Yeah. You're saying R equals V over I.
Yeah, the conductors
Is it?
Yeah.
Now you see, this is interesting, okay?
current is directly proportional to voltage.
This is what you think, isn't it? Everybody thinks this.
Yes, that's what
It's not really, though. This is a very common mistake. In fact, a lot of textbooks say that Ohm's law is this. A lot of books say Ohm's law is this. It's not. This is one of the questions I ask when we interview physics teachers. You know, there's a centre in in Cork. So when I interview physics teachers, this is one question I ask just to see if they know it. So Ohm's law isn't really this, even though a lot of people think it is. Ohm's law states that for some materials at a low voltage and low current and constant temperature, the IV characteristic graph will be linear. So Ohm didn't really say this. What Ohm said was, when you make the IV characteristic graph, at low voltage and low current and constant temperature, the graph here will be linear. That's what Ohm said. Okay, so that's kind of like saying I is proportional to V, but really, that's not too bad to say I is proportional to phi, because that's kind of like saying that they're linear. But we really want to reference the characteristic graph. Okay, so in the exam, you know, if this was a 2-mark definition, there'd be 1 mark for mentioning that it's linear or proportional, like you said, but then there'd be another mark for mentioning the characteristic graph. Actually, this might even be 3 marks, because you should also mention about it being low voltage, low current at a constant temperature. Okay, so can you write this down carefully? And if you're ever in an interview for a physics teaching job, and they ask you this, just remember it. Yeah. Yes.
So when they get this wrong, what do you do? How do you look at them?
I'd stay. No, exactly. I'd stay professional. I'm like,
So how many people feel like with this mistake? Saying
most do.
And they end up not getting the job?
Well, the problem is a lot of physics teachers, there's not a lot of physics teachers, so sometimes you still have to give the job to the person who gets this wrong.
Will you ask this for an interview?
Yeah. And for the maths interviews, I usually ask them to integrate something really difficult. You know, calculus. Okay, you got that? No. Now, this is called Ohm's law. It's actually not really a law. I'll explain why in a moment. So, this law is not always true. For example, for some resistors, we don't get a linear graph, right? And for some situations it doesn't work because maybe the temperature is too high or the voltage is too high or something. So this isn't always true, which means it's not really a law. You know, like remember when we did Newton's second law, we said F equals ma, right? That's always true. I didn't say, well, okay. Yeah, okay, I was hoping nobody knew that yet. Yeah, you're right. Let's just pretend we're back in Newton's day, 17th century, and we don't know about Einstein, okay? So we'll just pretend we're here. So Newton said F equals ma. He didn't say F equals ma when F is small, M is small, and A is small, right? Now, Ming knows there's a second half to the story, so we'll just ignore that. So this Ohm's law isn't really a law because you have to have these conditions to it, that, oh, it's when the voltage is small, the current is small, and so on. So it's not always true. If it is true, then we say the resistor is ohmic. Otherwise, we say it's not ohmic. So this is kind of silly, you know, if the law works, we say it's ohmic, and if it doesn't work, then we don't say the law is wrong, we just say the material is not ohmic. Okay, that would be a little bit like saying Newton's second law says F equals ma. If F does equal ma, then we call the material Newtonish, and if it doesn't work, then we say it's not Newtonish, you know, or something like this. So you need to know this word ohmic. If you have a graph like this, then we say the OR is ohmic. You got that? And we also looked at what the slope represents. What does the slope represent?
1 over R.
Yeah, it's 1 over R. But you know, you wrote this down already, didn't you? Yeah? Okay. Continue? Yeah. Continue, fellow? Yeah, okay. So, do you know, I have an example here, but to be honest, it's just, I think I'll just use this example I've done already. Okay? So, just using this example here, let's calculate the R. So we need the slope, don't we? So tell me, how can I get the slope here?
Pick 2 points.
You could just pick 2 points, couldn't you? Or what I like to do is you say it's this,
10 and 20.
yeah, divided by this. So this side here is 20, this side here is 10, so the slope is 2. So then what's the resistance?
1
Half.
Yeah, it's half an ohm. So can you add that to your graph? You got that? Yeah. Now there's other stuff here, but I don't think this particular example, which I'm not doing, the only difference between this example and the one I did here is the graph isn't a straight line. So we need to actually talk about that now. Sometimes you get graphs that look like this. Straight line. That's ohmic. Okay? What might give us something like this? A simple resistor might give us something like this. Okay? But what you also need to know for the exam is what the graph might look like for something like this. Does anyone know what it'll look like? No. Well, what'll happen is it'll be straight, but then if you make the voltage too big, it will start to curve down. What is happening to the resistance here? Well, yes, is it getting bigger or smaller? Be bigger. Yeah. So the R is not constant here. It is constant here, isn't it? But then at this point here, it starts to change. So we can describe it as being ohmic up to this point. Then afterwards, not ohmic. Okay. Now, they expect you to know this, or rather, they expect you to know this graph. VI. If you turn the cell around the other way, so that the current is going backwards, it means the V and the I will be negative. But it doesn't change the graph, it'll just still be a straight line. Okay, that's the resistor. What about for the lamp? It's the same. It's straight, then it flats. Straight and flattens. V and I. Okay. So there is another graph. Before I draw it, I'll let you write these two down. They expect you to know this in the exam. They might ask you to draw it. Oh, it's not really a problem. It's just, it means you take the cell and you turn it around. So if you look at your voltmeter, instead of saying 2 volts, it will say -2 because it changed direction.
The question we just did now is, so you are going to do R is equals to V over I, then 1 over R to get the slope.
So again, the or is 1 over the slope.
Yeah, then the slope is
Rise over run. Height over base.
so that's I over V.
Yeah. Did you draw that? Now the last one here. What about an LED diode? Well, the graph of the LED diode is actually quite interesting. Here it is here. I'll explain it. It's quite interesting. So, when the voltage is small, do we have a big or a small resistance here?
Small.
No, the resistance is big here at the start because the gradient, the slope is small, so the resistance is big. Now, what about here when the voltage is big? Then it's, yeah. So this means LED diodes, they behave in a strange way. You put a little voltage in it, there's lots of resistance, and nothing really happens. Okay, but then you put more voltage in it, and all of a sudden the resistance drops and it lights up. Okay, so what's kind of interesting about LED diodes is the more voltage you have, the less resistance you have. This is exactly the opposite to the lamp. More voltage makes more resistance in the lamp. Whereas with the diode, it's the opposite. More voltage makes less resistance. This is quite interesting with the LED diode. It's quite interesting. Now, earlier Ming said that for the LED diode, if you can't put the current the other way. Yeah, and you can see this on the graph. If you take the cell and turn it around to try and have the current going backwards, look what happens here. What's the resistance here? It's huge. Like the slope here is nearly 0. Agreed?
Mm-hmm.
So that means the resistance is nearly infinite. Which basically means that the current isn't going anywhere. Right? But if you force the current hard enough, the wrong way, eventually what happens? It breaks. And then all the current rushes through. The analogy I give is with the door. Okay? So if you picture them like the current, look. If I have a small current, nothing happens.
Yeah.
Then once my current is big enough, then I can come in. That's the forward way. Then what about the backwards? If I try to go the wrong way, I have lots of resistance. But if I push hard enough, all of a sudden the door will break and the current will rush through. Watch. No, it's not going to happen. Right, so when they ask you to draw this, the only number that they expect you to know is this number here, called the threshold voltage. This is the point at which the resistance drops. And that tends to happen at around about 0.7 volts, is this point here.
So we should know this number.
You should know this number correct. Yeah. Okay, draw that, please. Yeah.
Hi. Hello.
Hiya.
Can we interrupt the little
Go ahead.
message for students
Hey.
and staff? How's everybody? What's this? This January engineering?
Yeah.
Yes, great. So,
Don't look so worried. The news from our lovely government is that all schools, colleges, universities will close for 2 weeks from 6 o'clock this evening. So what we are going to do is we are going to give you tomorrow off, so there will be no classes tomorrow. We will use today to fine-tune our online teaching abilities and our technology. And from Monday onwards, you will be in a virtual learning environment. Okay, so we will have online classes. I presume you know that Tuesday is St. Patrick's Day, and that the whole country would generally close that day anyway. Yeah. So the college was meant to be closed Tuesday. It's nothing to do with the coronavirus situation, just to do with it's a public holiday. So Monday, Wednesday, Thursday, Friday next week, and all of the following week. So we do expect you to tune into class. We will be checking attendance. We will be running your attendance policy as normal. Okay. So you will get a timetable slightly modified, same teachers, same group, just online as opposed to in class. So it's closed for 2 weeks. Will it be longer? I've no idea. Could it be? I guess it could, but as of now, we've been given 2 weeks for this change to happen. Student services will still be working. We're still here to look after you, whatever welfare needs you have, and our tutor support is normal. Our placement team, Pádraig, Tiago, etc., will also still be working. We'll still progress your applications as best as we can. So we will continue working and progressing your study, your applications, etc. Do look after each other. It's weird times, very weird times for us all. It's new for us to switch to online learning. The situation is new for the country, for the world. All we can do is adapt to what's in front of us and change. So we just ask you to be a little patient with, certainly with our getting use of the technology. Stephen, I'm sure, will have the cracks.
Yeah.
The good news is you're going to see Stephen's face up really personal and close on the computer screen.
Yeah.
So
Yeah, but I told him before, I've been doing the classes in my pyjamas if this has to happen. So.
there you go. I'm sure it'll be a beautiful sight no matter how it happens. Right? But yeah, look, just be a little flexible and patient with us. It's new for us. We know it's new for yourselves as well. So we'll all just have to work together through it. NCUK will support us fully in terms of any adapting of programs or deadlines for exams, etc. You will not be disadvantaged by switching to online versus class-based learning. Okay, but just be patient, work with us, we'll all get through it, and we look forward to it behind us. We will still help you to get to where you want to go.
This is really great timing because I was just talking to the students that I don't think anything will happen anytime soon. So this is excellent timing on
Stephen knows nothing.
Yes. Yeah. No, don't be listening to me now.
David, isn't it you the question?
So, like, exams will
Yeah,
still...
that's what I'm going to get to. So, and do you guys have labs next week, or is that just biology? Is that
No,
chemistry?
we're not doing the physics lab till semester 2,
Okay.
so nothing soon.
So for you guys, the next thing you have is the end of semester 1 exams. We don't know what will happen with them, okay? But we're not saying to you today, goodbye now, we'll see you on the 29th. We're going to be in regular contact with you. You're going to be hearing from us every day, talking to us every day. So as soon as a decision is made on those exams, as soon as we know more, you'll find out about it, okay? Those exams may potentially happen. We could all be back in the college, or they might be deferred, or there might be assignments set instead of exams, or at the end of the year they might just adapt the percentages so that there is no exam, so the final exam is 80% instead of 70%.
Yeah.
You know, NCUK are going to be flexible because this is not DIFC's fault, okay? So they're going to work with us. The universities are going to have to be flexible. So it is our objective still to get every one of you placed in university in September, and we're all just going to have to be flexible about how that happens, okay? So DIFC is getting this information and we are adapting, okay? All our teachers are learning how to do online classes and we're going to start doing them next week, okay? You guys are going to have to be flexible, okay? You're going to have to change how things are done. You're going to have to go with how it is. But as long as we all stay engaged and work together on this, you know, we endeavour to have all of you placed in university in September just as planned, okay? Yeah. And you have the lovely Danny Lola taking care of you all as your class rep. So if you've got questions or concerns or issues, you know, you can talk to him. I'm going to be in regular contact with him, okay? And I would rely on you to just check in with your classmates all the time as well. And I trust you. I trust you. You're a good egg. Okay, so he'll be in either WhatsApp group, do you? Yeah, so just checking in with each other. I want you all to take care of each other and check in with each other and see you're all doing okay. During this time, really listen to the advice from the HSE, that's the Health Service Executive. I'll be forwarding that on to you. We'll have to just do whatever they're telling us to do. no risky behaviour, no, you're young, you're healthy, and this isn't a big danger to you, but it's, our responsibility to make sure that this thing doesn't spread, okay? So we're following all of the advice, we're taking care of ourselves and taking care of each other, okay? Questions? Yeah.
So does that mean like we have to buy food for the next 2 weeks?
Now, the government is saying there's no need to stockpile, but it'd be no harm having a few bits in. Okay.
Anyways, even in Italy, where we were talking earlier about being shut down, they still keep the pharmacies and the grocery stores are still open. So,
Okay.
and I was only just reading it this morning. I don't think shortage of supplies like this is
That's
something to
what
be
I read, yeah.
concerned
Like a
about.
toilet roll. Apparently, a lot of people buy toilet roll.
Yeah, I saw the videos online of people rushing to buy it. Yeah, yeah,
Be
maybe buying an
sensible.
extra roll wouldn't be a bad idea, just to be safe.
Just be sensible.
Yeah,
Just
Okay.
don't eat it. Just
yeah,
don't.
yeah.
Okay. All right. Okay. Thanks,
So it's
Stephen.
from 6 o'clock this evening
Yeah,
for
so
2 weeks.
We're not keeping you in till 6. Your classes will
Yeah.
finish at whatever time they finish today.
There
And
are
then-
And it's sorry, is
classes
this
today.
second and third level? Like this is
Everyone.
every
countrywide, yeah.
institution,
From
education.
Creches up to further education, everything.
Okay.
But like when you say online classes, like
So this time next week, for example, you'll be sitting at home in physics or maths?
This is physics now.
Physics class with Stephen.
Yeah.
Okay? You'll just be all in pyjamas.
Yep.
That's the moral of
Yes,
the
I think
story.
this is it. Yes, this will be
You'll
physics
just
in
be
pajamas.
using your laptop or computer, and that's how it's going to work, okay? Anybody who doesn't have a laptop or computer access,
And they all have their
maybe
phones
you
though.
might
They can
just,
watch the videos
or
on
you
that.
can
Yeah.
work out with each other. I'll come over to your house and we'll do it together. There's no law that says you can't see each other right now, okay? So you can work it out, help each other, work with each other. But the timetable will look pretty similar to how it looks now, except you won't physically be here. You'll just be logging in and following
And
class.
you know, Emer, even though they'll be at home, I'm sure some of them will still be late for class.
I'm sure that should go.
I think, yeah, possibly. Yeah.
The problem is some of the rooms they're in, it's a huge distance.
Yeah, but
from
they're at the
beds,
computer.
from
Yeah,
walls,
yeah,
you
yeah,
can do
yeah,
that,
yeah.
You know, you need to make
Getting
it
off
out.
stretching.
yeah, it's like three
so
much.
Yeah.
It's not easy. It's not easy. It's not easy.
Thank you, everybody.
Do your best.
Right.
and,
Okay.
Stay in touch, yeah?
Grand.
Okay.
Thanks for that, Brian.
And keep an eye on email.
Yeah.
Yeah, it's so different from what you said.
It's exactly the opposite of what I said.
Like it used to be a YouTube video streaming or something.
I
like
think
that.
what I'll personally, I have the software at home to stream on YouTube Live. I haven't done it before, but I have the software. So I think what I'll do is I'll probably post a link on the Moodle page to my YouTube channel, the live stream. I don't think I'll just do a live YouTube stream, right? Because that way you can still talk to me. You can still talk to me on like YouTube when you watch something live. There's a chat, isn't there?
And you can, after that, you can save it in.
Oh, I should learn to how to.
Yeah, like
Can-
after
you
the
can-
whole thing,
Yeah.
like
Yeah, the video can be saved too. Yeah.
Yeah.
All right. Okay. That's convenient then.
But it's going to be really slow.
What do you mean?
Because as you're writing the board, when you say, do you all understand?
I'll have to wait.
Yes.
Yes.
And someone says, I need coke.
Possibly.
So probably
So we'll still be waking up by 9 a.m.
this afternoon
Yeah.
there will be a lot of people go to the shop to buy some food.
Maybe, but I don't think
But you
so.
can actually just make a video and post it and then check the number of views. Since we all
Maybe. I would prefer to still do it live, so if there's questions, you know. But tell me, would you prefer YouTube or, you see, because we could use Microsoft and you could do, like, if you had webcams and you wanted to ask me a question, I could, you know, like a conference call.
Voice chat.
Yeah. Would you prefer to have voice chat or just the type questions?
you could take 13, 14 students at a time.
Yeah. Yeah.
Everybody will be making noise.
What?
Then how does that work? Right?
No, I think there's like you can do it so that you click a button to like raise your hand in the virtual classroom, and then you can like unmute.
Oh, okay, yeah.
Yeah, so like if this was online and someone had a question, I would see a little pop up saying, you know.
Well, all of you have to be in the same group first.
Yeah. But I can make the Microsoft team.
It's like playing like
This is something we
Fortnite.
quickly try so that we don't go stranded.
Exactly, because I don't understand anything.
Because
people
a
are
few
saying.
of us have our so we can actually just
Anything.
run a practical example for the next 10 minutes.
Like here,
I don't have it on this laptop.
and then
But I think I would like to do the YouTube. Because I like that the YouTube, he says it uploads the video. Yeah.
and you
It just seems less complicated.
It's maths and physics, so no issue. But how will Claudia do it?
Claudia? Why is that different?
Chemistry.
Why would
Will
it?
they all be the same type of?
What's Claudia's problem?
That's not his problem.
That's not my
He needs to
problem.
understand this.
I've got enough problems in life. I don't need extra problems. I'm just concerned about the maths and the
Me, I'm
physics.
not happy. Please, you should continue coming. Corona will not kill. I beg.
Corona will not stop us learning our maths and physics.
This one is complicated. This online.
Ah, it's not.
It's not. I remember Ebola.
Huh?
You guys, but in Nigeria, we had Ebola, so like we also did the online stuff.
All right. Okay. YouTube or
No, Moodle. Basically.
Moodle.
Yeah.
Yeah.
That's
They
in
would
Lagos.
record. Yeah, they would
Us
record
just
the videos
Google
and just upload
for
it,
that
and then
notice.
we'll watch it later.
Yeah.
You do that.
Okay. So look, did you draw this one now? Yeah.
Yeah.
Yeah. Okay. So there's a couple of minutes left. We'll just try a couple of the questions then, and then we'll finish. So I think Brian was saying no classes tomorrow.
Yeah.
Yeah.
And on Tuesday.
And the reason for this, you didn't say it, but I know what the reason is. It's so that the other teachers can quickly learn how to do what they need to do. So classes be on Monday.
Yeah.
Tuesday is a holiday.
Yeah.
So after this will be on Monday. So I think I'll just post a YouTube link at the top of the Moodle page for the live streaming. I'll probably do a test tonight of it. Yeah. All right, okay. So can you try those questions for a few minutes, please? How many are there now?